we'll be finding the Taylor expansion and radius of convergence of 1 divided by 1 minus 2x. What we're going to do is we're going to take f of x, and what's the formula for a Taylor expansion? K equals 0 to infinity, well, it's a limit, but still, of divided by k factorial, fk of 0, and this is the kth derivative of f. That means at k equals 0, it's just going to be the regular f times x to the k. So, to find the radius of convergence, we just have to use the ratio test on this. So first of all, we have to find an expression for fk of x. So by the power rule, we know that f prime of x is going to be equal to minus 1 times minus 2 by the chain rule, 1 minus 2x to the minus 2. Oh, sorry. Yeah. Then, by the power rule and chain rule again, we get minus 2 comes down. So we get minus 1 times minus 2 times minus 2 comes down times minus 2. The triple derivative, oh, sorry, this would be minus 3. The triple derivative, the minus 3 minus 2 minus 2 times 1 minus 2x to the minus 4. So you'll notice this is just equal to negative 1 to the n, yeah, times negative 2 to the n. And this is multiplied by just 1 times 2 times 3 going on, which is just equal to n factorial. And of course, we're actually writing in terms of k. So we have negative 1 to the k, negative 2 to the k, k factorial times 1 minus 2x to the negative k plus 1. And of course, this cancels out with this to just become 2 to the k. So, now that we've found an expression for fk of x, let's just plug that into the sum right over here to get, well, what is this at 0 actually? If we plug in 0 here, this term becomes 0, meaning this term becomes 1, so it doesn't matter when multiplying. Which means this is just equal to 2 to the k, k factorial, x to the k over k factorial. We cancel these two, and this is just the sum from k equals 0 to infinity of 2k x to the k. Now, how do we figure out when this converges? Well, by the ratio test, the ratio of 2 times k plus 1 x k plus 1 divided by 2k x to the k has to be less than 1 for x. So that means that since these cancel out and these factors of 2 cancel out too, we get k plus 1 divided by k times x has to be less than 1. Oh, okay, I got it. So, and this is the limit as the terms approach infinity. So this is once again the limit as k approaches infinity. So now, what do we find here? And of course, this also works for the absolute value of x as well. So, what do we find here? The limit of k plus 1 over k as k approaches infinity. This is just 1 plus 1 over k, which approaches 1, since 1 over k approaches 0, which means we just get the absolute value of x has to be less than 1, which means our radius of convergence for this expansion